Our next keynote speaker is David Magnusson. He is from Volvo Group Purchasing, Senior Buyer and Segment Leader, Additive Manufacturing. Please.
Thank you, Cristobal. Hola. I would love to do this in Spanish, but that will not be possible. Instead, I will do it in the official Volvo language, which is English with a bit of Swedish accent. So, my name is David Magnusson, and I will try to talk a little bit about first what we are doing at Volvo, but then what kind of challenges and opportunities we see when going from prototypes into actual functional parts that we dare to put on our trucks. So first of all, my name, as Cristobal mentioned, is David Magnusson. I work as a buyer and segment leader within Additive Manufacturing, trying to bring partners and suppliers together with Volvo into finding solutions within additive manufacturing. We are a big company. We are around 100,000 employees globally, 50,000 in Europe, and the rest spread out throughout the world. And many of you, when you hear the word Volvo, might think about our small sibling, the cars, but instead what I am representing is this industry, the truck industry. We have a lot of different applications. We have trucks that you can see up in the top in many different brands, construction equipment. We make engines for the marine industry in our Penta brand. We make buses. In the middle, you can see some autonomous vehicles that are being developed at the moment as well. You can even see one without a cab, so it's no driver. It's within testing right now. So it's a lot of interesting areas. And why is this important for additive manufacturing? 50% of the trucks we sell are customized to a specific customer. So we have separate parts just linked to one customer on a truck. That is what we really think is mass customization for us. Some brands, you might recognize some of them, Volvo Penta, Renault Trucks is big in Europe as well, and then we have Mack Trucks in the US, and a few more brands globally as well. Right now, we are 3D printing in 3 different areas. Prototypes, we have been doing it internally for more than 20 years, or around 20 years, I would say, mainly for plastics. This one is an example within our construction equipment. It's the right side of the part was 3D printed. We saved 18 weeks for this housing, and also 90% of the cost in prototypes. Here is a tool for our workshop. Every factory we have 3D printers in the factories. This one was produced in North America. They produce more than 500 parts. This is a paint cleaning, I don't know exactly, but it was, it's a good part for us at least. And finally, it's actually a functional parts where this is put on a truck. It's used as a spare part for us. We have introduced a lot of antennas in our trucks, and this one is an adapter that works with that. So we are good at prototypes. We are good at the tools. We and the rest of the automotive industry is struggling with production parts. And what do I see and what do we see in trucks as some of the main challenges? We have heard it, I think, in several presentations. We have heard it everywhere. Cost needs to come down. I'm a buyer as well. I'm the boring person when I go around here and then I ask all these nice things. How much does it cost? How does it cost compared to injection molding? This needs to come down. But at the same time, I'm not too worried about this because everyone knows about it. Everyone thinks about it. Everyone is trying to decrease cost all the time. The second one, I think, is for automotive. We need quality standards. When I speak to my engineers who do not work with 3D printing, they think it's a prototype technology. They don't understand that we can actually put this on a truck that actually performs, that actually managed to pass tests. And one of the reasons is that we don't have any standards to show them. This is being developed. It's also ongoing. We see it in a lot of these areas here. But that also needs to be better in the future to use it more. And then I think this is the main challenge, and that is mainly internal for us, but also for the companies working within this industry. We need a mindset change. I can give you one example. I'm sit together with engineers working with self-driving vehicles, and we have these semi-professional printers. And they were so happy about these printers because they say, now we can print some parts, we can feel the prototypes, they're just showing the CAD files, we can actually feel them, touch them. And then we asked, but why are you designing it for injection molding then? Why aren't you designing it directly for 3D printing when you're already 3D printing it? And they were, yeah, maybe we can do that. That could work as well. We need this mindset change that we can use the technology. We need to have good examples, both internally and also externally, that shows the strength of the technology, that shows which applications we can use it in. In the truck industry, I can see if we can do it for improving the airflow or the cooling. We can decrease the fuel consumption of the trucks, and that will bring money into our customers and make us even more competitive. If we can understand these things and really show them internally, then we can really make this technology take off. I think that is the main challenge. What benefits do we have? This is more fun. Challenges are not as fun, but I think mass customization. As I mentioned, 50% of our trucks are adapted to trucks. We can paint them in whatever color. We can paint the engine in whatever color. We had one customer coming in saying, I love your trucks. I love the new line of trucks. The technology is very good, but I like the looks of your old trucks better. Can I have a new truck with the look of an old truck? I think we quoted. I'm not sure if he bought the truck with that type of customization, but we do those things. And I think this is the one of the key benefits of this technology. We have heard about the Formula One before. I don't think the truck industry will be the leaders in optimizing weight, but performance. If we can optimize performance, we can make it better for the driver, who is our customer. We can make the fuel consumption go down, which can also then help our drivers make a better choice than buying a Volvo. In the truck industry, when you enter a contract with a supplier, you have a truck project running for 10 years, and then they need to supply spare parts for 15 years extra after that, because that is our brand commitments to our customers. So when we enter an agreement with a supplier, we expect them to deliver parts in 25 years from now. Many of the companies you see here today have not been around, with 3D printing at least, for 25 years. If we can 3D print a part, we don't need to invest in tools. So we can more easily, if we have a risk in the supply chain, we can change supplier if something within those 25 years happen. We can more easily move from one supplier to another. And if we don't have any investment tools, we can have parts in Europe, we can have parts in US, we can have parts in Asia. Worst case, we can ship them between this. So we can really reduce the risk of the supply chain by using 3D printing and then getting rid of these lock-in effects. We are a truck industry. We move parts all around the world, but at the same time, we are citizens of the globe as well. If we can reduce the environmental footprint by producing more locally, we can both have shorter lead times for spare parts and parts, but we can also help do a small part for the environment as well. I was told that this would not work. I'm not sure if I dare to try it anyway, but no, we skip it. You can go into the Renault YouTube website, and you can find a study they made on 3D printing engine parts. So they took the complete engine, and then they started thinking about additive manufacturing and how it could be done, which then resulted in, I don't remember the weight reduction, but I think it was a large weight reduction, and then also they reduced the engines with 200 part numbers, which also makes it much simpler complexity in the supply chain. So please have a look at that one. If you want to engage with us or with me, please contact me for 3D printing. The automotive industry is extremely interesting with not only additive manufacturing, but also self-driving trucks and electrification. Have a look here, or actually one of our competitors. It's an extremely interesting area to work in. Thank you very much.